En lep pozdrav vsem skupaj na današnjem dogodku DNA is our Identity, kjer se bomo pogovarjali o napredku, ki je bil narejen na področju genomike in genomskega testiranja. Današnji dogodek bo potekal v angleščini, zato bom tudi jaz priklopila na angleščino, pa ker imamo tudi tuje govorce. So welcome everybody to today's event about the advancements made in genomics and genetic sequencing. I would like to give a warm welcome to our speakers today. We have with us Professor Dr. Katarina Trebušak-Podkrajšek, who is a specialist of medical laboratory genetics at the medical faculty at the University in Ljubljana, and also works at the Children's Hospital in Ljubljana. Then we have Tanja Španić, President of Europa Dona Slovenia. We have with us Dr. Jeroen Adema, Clinical Sales Manager for Illumina in the EMEA region. Piarella Peralta, Patient Advocate and Engagement Specialist with Illumina. And then we've got Dr. Irene Kovač, Senior Laboratory Analyst and Researcher at the University Children's Hospital Ljubljana. Tremendous progress has been made in the field of genomics ever since the whole genome project was concluded. It took over 13 years to finalize that project, and that sequencing took $2.7 billion in costs. By today, we can sequence a genome of an individual for well below $1,000, and this reducing of price and the greater accessibility that it brought to researchers is bringing new findings and actionable insights that go from research to clinical practice. Today, we're going to try to highlight how has the situation changed in clinical practice, what progress has been made in genomic sequencing, but we will also talk about the limitations and realistic expectations that we have and can have based on the knowledge that's currently available. Before we begin the discussion, I would like to kindly invite Mr. Andrej Vuga, the CEO of Chemomed, to give his welcome remarks.
Good morning, everybody. Good morning, guests. I would like to say that we are here to spread the word about the importance of NGS technology to the broader population. Because what we have witnessed in the past few years is an important step in the direction of genomics in our health system, and that's why our mission is to bring to you the technology for saving lives, simply to say. And enjoy the conversation. Thank you. Thank you.
Thank you. For a light introduction into this topic, I would kindly ask Professor Katarina Trebušak-Podkrajšek and Dr. Kovač to start with an explanation of what are, when are genes deterministic and when it's not that simple, and to maybe highlight what are some of the things that we know today that we didn't know 20 years ago when it comes to the genome.
Well, yeah, genes are of course deterministic, but not in all situations, not in all disorders. It's the most easy example are monogenic disorders. When we have one gene and when there is a variant, pathogenic variant present in this gene, this is directly linked to the development of the disorder. So this is the simple example. But on the other hand, we have numerous disorders that are very common, for instance, obesity or adult onset hypercholesterolemia, that are so-called polygenic or multifactorial disorders, and where numerous genes along with several environmental factors are those who are contributing to the development of the disease. So when we are talking about the diagnostics of monogenic disorders, the task is quite simple. But when we are talking about the genetic diagnostics of polygenic disorders, the task is a bit more complicated, because even now with this major progress on the field of genomics, human genomics or medical genomics, we don't have enough data not on the genetic part and not on the environmental part. So, but nevertheless, the progress that we are seeing in these last few decades in the medical genomic field, it can be attributed to the development of the technology, because I think that in a way this is a confirmation of a saying that development in the science mainly depends on the development of the technology, but only secondly on the new ideas, new discoveries. So, for instance, if I give an example on genetic testing of hearing loss, 10 years ago, 15 years ago, all the medical genetic laboratories were analyzing only one gene with Sanger sequencing. And with this gene, we were able to identify genetic cause of hearing loss in roughly 20% of the patients, which is not it's quite okay regarding the fact that deafness is genetically very heterogeneous disorder. But now, with the progress of the technology, we can analyze all the genes associated with hearing loss in one experiment. And this experiment takes less time than Sanger sequencing of only one gene took 10 years ago. So how does this impact the patient? First of all, the results are much quicker. The data, the report that is leading to some deep change in the clinical management of the disorder is provided faster, and the diagnostic yield is much higher, because when we analyze more data, also it's more likely that we will find the genetic cause. And for instance, in non-syndromic hearing loss, now we have diagnostic yield around 60%, which is much higher comparing to the 20% 10 years ago. So I guess the technology has really impacted has really impacted the management of the patients with those rare disorders, with monogenic disorders. But for polygenic, there is some space for improvement.
Dr. Kovac, would you like to elaborate further? So how much do we actually know today that we didn't know 10 or 20 years ago, and how much do we still not know?
Well, we know much, much more than 10 years ago or 20 years ago, but still the most common approach in genetic diagnostics today is still analyzing only coding sequences of the human genome. So basically this represents only roughly about 2% of the whole genome. So basically we talk about analyzing very limited information when talking about whole genome, and trying to elucidate the diagnosis of some phenotypes, some disorders. And mostly for monogenic disorders, as Professor Tkaczak said, it's almost enough. And also the next generation sequencing technology facilitated that extreme expansion of knowledge about rare diseases, about cancer, about genetics overall, supporting the basic research in this field, as well as translating this knowledge, this accumulated knowledge into the clinical practice. So basically what we do today is still analyzing a very limited space of genome, trying to find the cause of the disorder, when we hope that in the future we'll be able to tell much more from the whole genome sequences. So basically that the whole genome will actually tell us the whole story.
Mm-hmm. Dr. Adima, can you talk a little bit about how is technology advancing? I mentioned earlier that the testing is becoming more and more accessible in terms of the price, but what's changing on the tech side that's making and enabling this accessibility?
So there's a lot of movement on the technology side, and on the library preparation part, so the preparatory part of your sample to the sequencing, which is analyzing your genome, there's been major steps to increase the scale. So let's say if you want to do a genome, you can either do it very quickly, but also you can do many more genomes in one single run, which is critical because in the context, if you want to go for genome sequencing at a later stage for a larger part of the population, you need to have an instrument that cannot just do one sample, but can have hundreds of samples that can be done. So that's the big technology move on that part, which is actually now at a point where cost is accessible, workflow is easy to implement, it can be fully automated, and then the newer struggle is for the interpretation side of things. So the wet lab, the laboratory part is great, but then there's still the way of getting access to all of the data and how to make sense of the data that you're getting. So if you get your genome sequenced or your exome sequenced, you get thousands or millions of variants. And how do you know what is the variant that's causing this specific disease, or as was mentioned, the polygenic disease? And for that, we need good software that can first host and transfer the data, but secondly also help by using bioinformatic tools to give information to the clinician as to what are the highly likely variants that are causing the symptoms or the phenotype that are being displayed. So this is an area where there's still a lot of movement to also make steps into the analysis part of things. Still on the technology side, there will be still continuous development to drive further down the cost and increase the scale. So that would not be a barrier for not only people that are coming into the hospital with an illness, but maybe even go for a healthy population and take ownership of their own health through genomics, and then trying to maybe go for a more preventive care approach rather than reactive.
Into that area, I would like for us to see a statement from one of the speakers that unfortunately couldn't join us here. So we will hear from Dr. Nate Yellen, who is the president of the Association for Rare Diseases, William Julian. He couldn't join us in person, but he recorded a statement about how does the association and the parents of children with rare diseases see the meaning and the significance of accessibility of genomic testing.
Ja, v društvu William Julian zagotovo vidimo velik pomen genetskega testiranja. Torej, moramo vedeti pač osnovo. Redke bolezni so dejansko prvi vrsti zelo redke, kar pomeni, da za njih ni nekih klasičnih diagnostičnih postopkov. Hkrati so tudi večinoma genetske. Torej, vsaj 80% redkih bolezni je genetskega izvora, pri čemer so pač te bolezni večinoma tudi monogenetske, torej nimajo kompleksne genetike v ozadju. So pa to hkrati zelo hude bolezni, torej povzročajo izredno težka zdravstvena stanja, so doživljenjske praktično, žal večinoma neozdravljive, za več kot 95% redkih bolezni ni nobenega zdravila in povzročajo težke okvare, invalidnost, hude bolečine. Torej, je v bistvu diagnoza pri redki bolezni dejansko velikega pomena, če tudi pač to ne pomeni, da je potem možnost zdravljenja. Zdaj, zakaj je diagnoza kljub temu toliko bolj pomembna? En vidik je gotovo psihološki vidik. Torej, redke bolezni večinoma prizadenejo otroke, in starši se znajdejo v situaciji, ki je zelo težka z psihološkega vidika. Torej, in odsotnost neke diagnoze, torej, da se ne ve v bistvu, kakšno točno bolezen ima otrok, to stisko še dodatno povečuje. Ker če bolezen ni diagnosticirana, dejansko lahko zdravniki dajo zelo malo informacij, kakšno stanje sploh ima otrok, in so starši resnično v nekem takem brezizhodnem položaju, ki ga velikokrat pač preveva obup. Torej, ni informacij, ni neke dokončne prognoze in pač predstavljamo si situacijo, da ne veš, kaj je narobe z otrokom, ne veš, kaj se bo zgodilo, ne veš, kaj bo čez en mesec, ne veš, kaj bo čez 1 leto, ne veš, kaj bo čez 5 let. In dejansko je ta psihološki vidik že v tem smislu velikega pomena, ne, če se bolezen diagnosticira, da dejansko lahko pride dosti več informacij do staršev, da se seznanijo. Hkrati pa to odpira tudi druge možnosti, ne, da se le iščejo neke rešitve v smislu razvoj na področju oskrbe, obravnave redkih bolezni je v zadnjih letih zelo velik, ne, in na mednarodni ravni obstaja veliko nevladnih organizacij, združenj, recimo, ne, ki združujejo bolnike po celem svetu z določeno boleznijo oziroma z sindromom, ki lahko ti starši opolnomočijo. Hkrati, kar je še pomembno, ki jim lahko tudi ponudijo recimo možnost vključiti v kakšno klinično študijo. Ne. Torej, konec koncev lahko tudi sama diagnoza pomeni neko perspektivo, ne, v končni fazi za samo zdravljenje. Ne. Torej, mi poznamo recimo konkretne primere, kjer je v bistvu diagnoza, pa v tem primeru hitra diagnoza, ne, rešila življenje otroku, ne, kar se je izkazalo, da gre za bolezen, za katero je ravno prišlo neko novo gensko zdravljenje ven. Ne. In tu recimo je bila neka hitra, pravočasna diagnoza ključnega pomena. Ne. Zdaj, genetika, genomika je v zadnjih letih ogromno napredovala, ne. In še ne tako dolgo nazaj je bilo veliko daljša pot, recimo, ne, priti do neke diagnoze preko genetskih testov, ker genetski testi niso bili tako obsežni. Ne. Danes so dosti bolj obsežni, tudi v bistvu je že nekako rutinsko v laboratoriju, da se lahko naredi pač genomska preiskava, ne, in je tudi nekako to diagnosticiranje, ne, postalo hitrejše. Seveda, ker so pa redke bolezni tako v bistvu kompleksne v smislu, da se lahko nahaja kjerkoli v genomu, ne, še pa kljub temu nismo tam, da bi v bistvu trenutna neka tehnologija lahko omogočala neko hitro diagnozo čisto vsake redke bolezni. Ne. Tako da tu še vseeno obstaja ta problematika, ki je značilna za redke bolezni že od začetka, torej diagnostično odisijaba, kjer lahko traja veliko časa, tudi več let, da dejansko pridejo do diagnoze. Torej, še enkrat bi poudaril ta vidik, diagnoza vsekakor je za družino otrok z redkimi boleznimi zelo pomembna. Zdaj, mi imamo v bistvu različne izkušnje, ne? Mi smo ogromno v stiku z družinami, starši. Ne? Zdaj, nekako, tudi menimo, da se tu nekako situacija izboljšuje, nekako so že zdravniki tam, kot sem rekel, ker je večina redkih bolezni je genetskega izvora, ne? Je torej že nekako osnovna indikacija, da se takoj začnejo delati genetski testi. Ne? Torej, mi verjamemo, da se zdravniki tega že zelo dobro ali pa če dalje bolje zavedajo. Ne. Imamo pa vsekakor izkušnje, če ne druge, iz preteklosti, ne, da so mogli starši prositi, prepričevati, ne, da se naredijo neke genetske preiskave ali pa, če ne to, da se naredijo neke dodatne genetske preiskave. Ne. Torej prepričevati v smislu, da je potrebno iti en korak naprej, da je potrebno narediti več, ne? Torej ta del vsekakor je še vedno prisoten.
Knowing the diagnosis is very important, even if there's no clinical intervention that could impact clinical outcomes. So perhaps we can start with a few comments here. So how much of the findings that happen in research get translated into clinical practice and are actually even actionable? How do you see that? And then Tanya and Piarella, you can also expand from the rare diseases in children in oncology and some of the examples that you came across in your work.
Well, it's hard to say the percentage of how many of the clinical, of the genetic findings are actually actionable. But we have to keep in mind that diagnostic genetic testing is performed always on the basis of some clinical indication. So it is not performed just for the fun of it, but for the, because of the anticipation that this result will impact the clinical management, if possible treatment. But of course there are cases when the treatment is not available, but again this kind of knowledge is important because it facilitates research, search for new treatment options, and at the end of the day, in the best case scenario, novel treatments are developed, and this again helps future patients with the same disease. So it is hard to say every report is actionable, but it has limitations, of course.
Yeah, the same goes for another layer of actually genetic testing impact on the society, and that one is that when parents know what's wrong or what's happened to their child, they can actually go to get their reproductive counseling. So basically they can get help to prevent another child if this is genetic and it's inherited from both parents. And then they can have the healthy child with the help of the medical system, the reproductive counseling and so on. So basically the genetic information alone has a profound impact on the family that receives the diagnosis and on the society as a whole, because it can, if we put it bluntly, it can save money actually on the global scale when we can help the family with a genetic disease, a disorder, to have a healthy child. If we can treat the actual child, for example, with these novel approaches for genetic treatment of muscular dystrophy or any other potential disease that we have now treatment for, we can actually reduce the burden of those rare diseases on the society, on the medical healthcare system. So basically, it's crucial to have this information. And as was said before, when we will have in the future, when we will have the information beforehand, so basically when we will do the population screening based on genetics and genomics, then the options that are potentially available are astronomical.
Tanya, tremendous progress has been made in the treatments that are available in oncology. Some cancers are turning into more chronic diseases, so the quality of life is what's changing for many cancer patients, even if the survival rates are not expanding as much as we would like. What's your reflection on the impact that genomics and progress has in oncology?
Well, yeah, in the past, let's say 20 years since we know the genome, much changed in cancer society as well, but as you said, maybe the direct impact we will probably see in the next coming years. Definitely this will help us understand. We have genetic tests for germ mutations like very known BRCA genes, TP53, since more than 10-15 years. And so far, we didn't have even appropriate treatment for this. Now we have in ovarian, in breast cancer, we have actually treatments that are responsive and are available for patients, for carriers of these mutations. But if we move further to the next generation sequencing or the gene signature of the tumor, well, this is something that's happening daily, and where the news and updates are daily coming in oncology, and definitely that helps patients and clinicians a lot. But on the other hand, I think that we still have to be very careful in this. So what to do, when we have to know when to do this. It's not appropriate for all cancer patients, because one thing is that patients are very aware, and we have access today to everything. So 20 years ago, no one went to medical library to read the journals that were available, and they're available still today. Today you just go on internet, you Google, and you find it. So people actually have access to this information, and it's very hard because people don't understand it. Lay people don't understand this. So it's really maybe also a lot on us as patient organizations to do these bridges and to help lay people understand this. So when to do this, we have to be very cautious. What do we do on basic research? What translation science is doing, and what is actually available and useful information for patient today? Of course, we are all looking forward. When I was diagnosed in 2008, so I wanted to do a microarray on my tumor, and clinicians were convincing me that this doesn't exist, which was very crazy because I was a PhD student working on microarrays. So, you know, you don't know who is your patient, and actually I still have my tumor samples, and I still don't know if I will do microarray or not, what this will mean today for me, what this information, because I've done all the treatment. I cannot change that. So we need prediction tests to choose the right treatment that we have. And today I see these tests in addition to pathological and pathology and histology that we have available. And definitely we see changes, of course. Well, breast is a little bit different, but in cancers that had poor prognosis 10 years ago, we see a tremendous progression in melanoma, lung cancer, and hopefully soon in pancreatic cancer. But this is not something that we should push. I wish we do. But as a scientist and as someone who loves genetics, I would do this to all tumors. But on the other hand, we have to be very realistic and not give people fake hope that we will treat them or that we will give them their health back. But we really have to be cautious and take this into account, when to do it, how to do it, and what to do with these results. It's very cool. Okay, I know which genes are overexpressed, what are mutations in my tumor, but if I don't have the treatment for that, this information, for me as a patient, is very useless. And maybe just gives me some fake hope that I'll get healthy again.
Piarella, Peralta, so what do you see with the patients that you are working with? Dr. Spanish opened up a very important topic, and that is the education of patients, the awareness of patients. Patients read, they can find information, but then there's the doctor with the authority that can just say this doesn't make sense. So what can patients do then? What do you see that, how much interest is it from their side to perhaps ask for genomic testing?
Just before I go into your question, I've been listening intently at all the arguments put forth, and your questions about time earlier and what is possible really point us to the fact that we are a very historical moment with a moving target. We understand the possibility, and as Tanya says, we need to look at it in the context of patients and how this helps. If you hear that 300 million people in the world are facing rare disease, you see the burden of cancer. In Slovenia, a country with 2 million people, 150,000 people are facing rare disease. It is incumbent upon us to think in a more strategic, important way, facilitated by the technologies that we have today. So it is a moving target. And going back to your question about looking at patient stories and how that helps us solve the puzzle of how we do, when we do, and what we provide as information, in the context of genomics is illustrated, for example, by in Slovenia. Somebody who is a mother of a child with a rare disease who knows where the gene defect is, and then she's pushing research to find out how to treat her son. And you see, so patient advocacy is actually a story of tragedy, because people are confronted, with terrible news and a difficult situation, how to manage disease, but it's a story of resilience as well. Because all these people stand up and want to change the system in a way that it helps solve their problems. So how do we solve the problems as a society? And perhaps genomics is offering us an opportunity to change the way we understand disease and how we intervene. So in the oncology space, we see the opportunity. Patients Google, they understand. I know a patient in Spain who was facing a sarcoma, and she went to her doctor and said, I see there is a clinical trial that I may be eligible for, but I need to do the sequencing, and no, maybe, you know, it's difficult story. She was resilient. She wrote to the principal investigator in the hospital, and he said, well, it's going to be difficult, you are somewhere else. She went to him. She got the sequencing. She has a sarcoma for which they told her there's nothing to do for her, and they did the sequencing. Now she has a targeted treatment. So it is important, and indeed you have a very clear role for patient experts and patient representatives. There is a role for these advocates, experts, to be a bridge with the general population to say, listen, in most of the times maybe we don't have something that will help you. But what we need to do in the context of technology and the context of data is, if we don't look for how these complex diseases are behaving and why when something is expressed and treated, some patients respond, some patients don't respond, you know, how do we tailor all of these things? How do we understand disease? These diseases are really smart, so we need to be smarter to help these people solve their problems.
If I may just add here, as you mentioned, Piarella, is what all that we see, it's actually personalization of the treatment and support, either rare disease, cancer, or any other non-communicable disease, is actually, this is working towards the individual patient. So, but it actually is a very broad multi-stakeholder thing. So technology is doing something, clinic is doing something, and then there comes industry or whoever that provides this. So what we see, and in all of these communities, well, cancer community is learning a lot from HIV community, which is very involved in the research and the development of the treatment in the past 30 years. This is actually now, as you said, maybe really a historical thing that we will actually have to work all together.
Yes.
Informations are available. You are providing some very good diagnostic tools. There are patients with very severe disease that we probably lost them within a few months in the past years. And there's another very important thing of research and development of this treatment. And at some point, we are talking about big data and everything for more than 10 years. But at some point, we will have to move forward and bring all of this together. Because we are talking also about patient centricity for so many years, but in reality, unfortunately, that's not the case. As you mentioned, the patient has to be the one, and not all patients are so much informed or educated as some mothers, which we know her very well since we worked with her and everybody, and patients like that lady from Spain. These are individual cases that saved their lives or are helping. But as a community, as a society, if we don't start to work together, there will be no progress in 30 years.
I agree, because just to go back to your point, even now in countries where you have full access to a genome, it's not happening. So the problem here is we have a population who may or may not know about a test that they need to ask for. But if you can imagine, you just learned you have a devastating situation. Either you have cancer or you're facing, a child with a rare disease, and then as a parent you're thinking, or as a person you're thinking about your future, all kinds of things, and then you have all these people coming telling you, oh, you need to do this or this or that. And I think it's incumbent upon us with multi-stakeholders, multi-expertise to come together and move the needle. Because even if the technology makes it happen, even if governments provide access, it doesn't mean that we're going to have a clear success. It is really a need for us to work together. And this is one of the reasons I am very privileged to have the opportunity to be at a very technology point and have the opportunity to learn from the communities of what matters to them. And guess what? This is the way we need to move forward. And with the experts, this is the way to move it. So that persons who are confronted with this very devastating news don't need to fix everything. You know, we should be able. There is enough capacity intellectually, technologically. It's now the time for willingness to move forward.
Maybe if I can add, like there is already positive movement, right? That the technology has been forcing the system to change, right?
Yeah.
If in the past, like a clinician would order a test specifically for that cancer type and test only for that. Now in some well-developed countries, they have been putting together these multi-stakeholder, what they call molecular tumor boards. So the more complex cases, they put people into one situation, oncologist, pathologist, physiotherapist, pediatrician, dietitian, all kinds of stakeholders. And then the more complex cases are going for more comprehensive profiling. So we're not looking at specific mutations. We're looking at the cancer as a whole in the context of personalized medicine. And there might be therapies that were originally approved for that cancer type, but in a good conserved clinical trial setting in the hospital, they say, okay, look, the tumor, if we sequence the tumor, it shows the same profile as a breast cancer, while this is maybe a lung cancer. Yeah. And based on the molecular pathway, that would be a treatment that we could apply. So in a good setting, we could still apply a treatment to someone that would actually otherwise have no treatment options. And it has to be done in a very good setting. But this is already pushing the system also to look at how do we reimburse these tests, which are the stakeholders, who are the patients that are eligible for those tests. Because also, to the story earlier, clinicians are also in a position where it's difficult for them, because if your patient comes and says, okay, I want to do test XYZ, and you can do test XYZ, but the therapy is not available in your country, there's also a very awkward discussion with the patient. It's like, look, yes, that drug would likely work for you, but in this country, in this setting, we would not be able to offer it to you. And then you get very crazy situations that people trying to raise funds to go to the US for very expensive treatment, which is also not something that maybe you would like to have.
I'm sorry.
I think we managed to outline that this is far from an easy topic. It's a complex with several forces that are perhaps working against each other, power asymmetries, information asymmetries. Technology at the end of the day is just one thing that can potentially be the least of everyone's problem. But just to outline the perhaps the accessibility to information, testing and actionable insights, if we move to that, because we kind of started talking also about the who at the end of the day is going to be the payer of all this care and testing. And I want to touch upon the accessibility of testing. And perhaps we can start with you, Dr. Adema, given that you work across the EMEA region. What kind of differences on a broad level do you see between countries in terms of how they approach the introduction of testing and what it can do for patients?
Yeah, so if you look at the accessibility of genomics, it's very unequal, right? Depending on the country or the situation you live in and how vocal you are, you can get easy access to a genetic test or there's no access to genetic tests. So if you take countries like Germany, Netherlands, where I'm from, genetic testing is very accessible. It's paid by the national health insurance to a certain extent, but there is access to it. If you go to Africa, like they don't necessarily have an interest in genetic diseases because they have much bigger burdens on HIV, TB, and other infectious agents. So there, you have to be quite vocal on that. And that's also what we're trying to do, is to work with local labs, local agencies to do health technology assessment on how the technology could benefit and what is the overall cost for the system. Because if there's a very good case for various of these topics to show that the genomics testing at an early stage actually reduces the healthcare spending, right? If you have a patient, like for example in the rare diseases, on average it takes around 7 years for a child to get a diagnosis. And in that 7 years, they visit multiple clinicians, they do MRIs, CAT scans, etc. So the cumulative cost is very high. Versus a genetic test that could get a result in a week and would give more predictive action. The same in oncology. Oncology and cancer patients are spending a significant part of the healthcare budgets of countries today. And there's many new therapies, which are great, but they're also generally quite expensive if we talk about immunotherapies, targeted therapies. And therefore, there's not an unlimited budget from the healthcare budget. So they have to be selective as to say, okay, we need to really carefully select those individuals where we can almost be sure that giving a targeted therapy has a good outcome for that patient. So yeah, depending on the country you are, in Germany there's full reimbursement for various tests. If I'm working in Eastern European countries or in the Middle East, even if there's funding, there's not a system that says, okay, this is a genetic test that can be reimbursed. So yeah, there's a lot of work to do in that space.
If I may add, in Slovenia we are really lucky. So the genetic testing or genomic testing is very accessible. It is also covered by the national health insurance companies, and moreover for the field of pediatrics. I think that also the physicians, especially at our clinic, maybe not on the primary level, but at the clinic, are very aware of the fact that genomic testing can profoundly affect the way of management of the disease. And it's quite often applied really early in at the beginning of the development of the disease, which is in a way sometimes difficult because it's much harder for us to interpret the data, because we always interpret genomic data together with the clinical data. And if you have a really small child of 5 days, the symptoms and signs are not really clear. So this might be even, I mean, it's really good to have early genetic testing, but sometimes too early it's not good, because it does not give all the answers. But yes, it's really important to have availability to this kind of test. And also for the oncology, there is the data, I mean the testing is available, it is reimbursed. There are some discrepancies in some fields, because maybe physicians in some fields are not educated enough. They are not aware of the possibilities that genetic testing could offer, especially in adult patients. But in the pediatric field, in the oncology field, this is really accessible and widely used. And that's why in our clinics we are, in a way, overflowed with a request for the testing.
Yeah. Maybe there should be addressed also this lack of obvious progress. So basically, the benefit of the patient. Well, if you remember in the 90s, in the last century, the Human Genome Project was advertised as the project that will end chronic human disease. Basically, when we know the sequence, we know everything. And that's why it was because of the idea that the sequence directly translates to the phenotype. And when we sequenced everything, a completely new horizon opened. So basically, it was the same as Christopher Columbus traveling to India and finding America. So the idea of genome function completely changed. So there was no straightforward line anymore, and that's why maybe some genetic advances are not so easily translated to the benefit of the patient, because there are many unknowns still present in this field. So how to connect all the dots basically is the main question now. How to harvest the data that we have to benefit the patient. That is one of the greatest questions now in this decade, for example.
Also, the benefit of genetic testing for an individual is very different from where you are, right? So if we look at the genome reference populations, so the reference that you're comparing all of your data against, 85% is based on Caucasian population. So more developed countries that were doing it. So for someone that's in Africa that has genetic disease, oftentimes they might do the sequencing, but that would not show any relevant variants, because actually it was not in the reference genome. There are specific new things, and a lot of diversity is coming from Africa. This is the origin, but the databases are not represented. So also, as Lumina, we take an active stance to try and promote sequencing in those territories to enrich for the database, because a stronger database is going to, in the end, benefit all of the individuals worldwide.
It almost seems like there's after the whole genome or the human genome sequencing project was finalized, there's now this new wave of research happening on national and regional levels. So we've got England with its Genomics England project, which was established to sequence 100,000 genomes from around 85,000 NHS patients with rare diseases and cancer. Estonia has a national biobank with genomics data of 20% of its population. Finland has a national genome center, and on the EU level we have the European 1 million genomes initiative. That all these projects are trying to bring more clarity in this discussion. Perhaps an additional comment about Slovenia and the screening programs that also come into place here. So when we try to screen the population, what are perhaps some of the examples or thinking here? Because later we will also talk about the expectations of the future and the hopes of the liquid biopsies that would perhaps bring additional information. But so screening programs, newborns, prenatal testing, what's the thinking here? You know, if we see that there's something that we could tell the patient, but might not make sense to tell the patient.
Well, with the screening, there is always a multi-level question of ethics, law, access to treatments. So basically, after the test, what can we do? And also finances, yeah, of course. If we can cover the cost of everything for the whole population. And then, regarding the genetic testing, there is a question of what to report, actually. So basically, we talk about the child that has no known phenotypic or expressed disease signs. So basically, we are talking about healthy child. And now we read his or her genome or genomic data, and you have to tell from this data, this limited data, what will be wrong, if there is anything that could be wrong. So basically there are very strict rules how and when can we do it. So we cannot report everything. Look, we see that your child would have the Huntington disease. That's something that's not fair to the family, because we don't have treatment. The Huntington is still basically something unknown in the adulthood. And the quality of life that would be destroyed by this information is much more severe compared to the actual Huntington disease at the end. So basically we cannot report every information from genome to the family, because we have to take into account the family quality of life and the solutions that we can offer them when we report them the genetic trait that will affect them profoundly. So basically, in Slovenia, for a long time, there were only 2 diseases that were screened for. And then in 2017, we added a multi-metabolic panel so that we can cover basically the metabolic disorders. And now we are adding several other diseases, including, for example, spinal muscular dystrophy, that is genetic test. But for that genetic test, we have specific rules how to report the result and how to treat. We have treatment for the child, for affected children. We can offer the solution to the family. And for oncology, there is a completely another universe. So basically, genetic testing in the newborns is something that will happen, definitely will happen, but with the strict rules and a way of reporting it to the family.
To add a point here, if possible. So, so 2 points. I value what you say, and it brings me to the thought that we need to think about it also locally. For example, because the example you mentioned in the Netherlands, Huntington, is actually reported. So it's asked, there is a population that is affected, and they know about the impact of the disease later in life. So a lot of them choose to know, because they then can make decisions on their milestones and even prepare their later care. So that is a very important point. Another point is that we lack enough insight into what really actually people want. So it is important in these ethical discussions, and Tanya is an expert on patient inclusion as well, and the patient centricity, what you said, we talk about it, but we really don't do it. So the data to say what the population, the patient population facing this disease wants is not enough known. So these are aspects that we really need to consider and include as we move forward. So this is a population that really is not there when decisions are being made about how decisions will impact their lives. So we need to generate this data and these insights of what people actually want who are facing that disease.
Maybe in neonatal testing, I think that for a long time it will be really important to report only actionable variants, like Jernej said. But we will have this data, and this neonate will grow up, and when he will be, or her, 16, 18, he will decide the fate of his own genetic data. Does he wants to know that he is a carrier, that he will get some oncological disorder, some neurological disorder? Is he a carrier of a disease, so that he will transmit some disease that is not affecting this person per se, but will affect his offsprings? So the data will be there, but I think it's really important that the patient will be in charge of this data. And actually, it is in a way already organized this way in testing, in medical genetic testing, because the patient is owning this data.
Yes. Yeah. Yes, because I know an example in pancreatic cancer. I mean, these disorders are not unknown in these families. They know the burden of the disease from their relatives. So they already are understanding that they have a chance of this. And in the Netherlands, I know the case of pancreatic cancer, a man who passed away. The wife is now a very active advocate. 3 of the children potentially carry the gene and mutation, and 2 of them chose to know. 1 of them don't want to know. So it has to be in the context of what people really want to do.
It's also like the background that people have, right? So if you go for countries or regions where there's a high consanguinity rate, there's a much higher awareness that there's whole families are impacted by genetic diseases. And to the point earlier, you could act actively as a family planning to try and eradicate those diseases from your family tree. And that is empowering people rather than just having more children that die at a young age because that's a disease that's in the family. They can take ownership. And there's a lot of ethical decisions on that and or discussions, but there's even countries that say, look, actually, we should do it even in an earlier stage and do it at a premarital screening stage. So it's a point that in those countries where there's such a high consanguinity rate that it's something that the government advises expecting couples to do, just to ensure that there's not a continuous growth of this disease.
It's not just a local, it really depends on the culture and the country where we are. But in all of this, it all goes, as you already mentioned, also always the patient or the person is the owner of this data. We barely mentioned biobanks and these databases, but even after the clinical trials, the data are locked by sponsors, which is totally unacceptable for if we want to move forward. Okay. But in this regard, you mentioned Africa and so on. Even within Europe, every single country has its own health system. And even Germany, even though it sounds perfect, you know that every drug after 1 year, if it's available after EMA approves it, after a year it goes through evaluation and it could be withdrawn. UK left the EU. They have NICE. They are now even more better maybe access as other EU. But in that case, at least in oncology, but probably also in rare diseases, I always want to point out that Europe and North America, maybe Australia in a way, are one world, and all other world, and we are minority. If we look, you mentioned Caucasian trials and so on. US is trying something to include more other ethnical groups, but Africa, Asia, South America, that's totally other world. And these countries are coming up now, especially in cancer. Cancer incidence is growing. They are becoming more developed, or maybe not so developed if they're developing so many cases. Probably in rare diseases, when this nations will have access to all of this, suddenly this population will be much more frequent, and they will have even maybe some other diseases or conditions that we are not aware now in this.
This is already happening, right? So,
Yes,
like,
yes, I know.
we have a lot of discussion
Yeah.
with African governments because they are actually facing a double disease burden, what we call it. So,
Yes.
like, they have the communicable diseases of HIV, malaria, TB, etc., which is ongoing, and on top of it, the population gets older, gets more wealthy, and they get non-communicable diseases. So, at some point, their healthcare system has to support both, which is not something that they can sustain. So, they're more looking at leapfrogging technology, and maybe it's a segue to the futuristic things where actually rather than trying to diagnose a cancer patient at a late stage where therapies are becoming more expensive, maybe we can do a screening program for high-risk individuals and tear them out earlier where they still basic chemotherapy could have a good impact.
This is actually, Middle East is already happening, that you mentioned. They have also, luckily they have enough money so they can cover it. But
yeah, but also because of the consanguinity, they have more conserved cancer types. So it's easier to address the whole group. Yeah.
We kind of naturally transitioned to thinking about what the future is bringing and what we expect. So I want to, as the last topic, go into that segment as well. So what are your expectations and hopes in terms of the future technology, data management and AI that will potentially make just the analysis easier because we do have larger amounts of data? What do you see that patients hope to see in the future or expect to have available in, let's say, 10 years' time? And we can maybe just start and go from one to the next. And yeah, feel free to compliment each other as you did so far. So
basically, what we wish.
in ideal world?
Yeah.
Or not, or in a real world?
Let's say for Christmas.
This Christmas.
So basically, the data can be now easily generated. This is something that is a routine. We can do genome, we can do exome, we can do double genome if we want. We can stack the data so much that we can cover the genome 100 times, 1,000 times, whatever, if we can afford it. I believe that it will go cheaper, even cheaper, because that's the natural progress of everything that we do. On the other hand, all that data represents a bigger and bigger burden in the sense of storage those data, to maintain the storage so to maintain not the biobank, it's a digital bank or something like that, and to also interpret the data in light of novel discoveries, novel knowledge. So basically, how to pull everything together. And there, I believe that, as we discussed before, that the artificial intelligence, machine learning algorithms, bioinformatics overall will help to bring together this progress and to facilitate faster and easier interpretation of a genomic background of a disease. Also, with the accessible technology will come novel discovery. So we talk about rare diseases of 80% of them being genetic. I said for the rest of 20% we don't yet know the genetic background, but most probably there is something in polygenic sense or in non-coding regions or anything else. So basically the knowledge will expand. It's inflation of knowledge actually that is already happening and will have and will accelerate in the future. And this will be an art to bring all this together. So basically we wish it for this one click, you know.
It's come together. Oh, yes.
Oh, of course. So that would be the ideal world, yeah.
So I take this leapfrog to say we've managed to put together the puzzle and we can have access to it, and we have changed the way we approach disease. And I hope it will make evident that access issues are solved. So the way we develop, the way we look at disease, the way we think about outcomes has been addressed, and we're all doing it. Everywhere in the world, there is access. And patients have the solutions they want and they need.
Yeah, so I've been in this field for the last 10 years, and still it's exciting to see how the technology develops, and also every time we realize how much we're still at the beginning, right? So we're also talking here about patients and access to care, etc. what's today, but ultimately you might, as an individual, you want to take ownership of your health. Like we are already talking about our diets, we're talking about exercising, maybe proactively doing something, and genomics can play a key role in that. But I sequence my own genome. I have no clue what to do with it, because I cannot go look at all the variants and understand whatever I want to do with it. So at some point, far beyond in the future, we will know our genomes and we maybe proactively can act on that. But on the shorter term, what we already see is that we're talking about genome sequencing here, which is DNA. But that's not the final answer. We have been adding other layers like epigenetics, transcriptomics, proteomics, which is also going to maybe address some of these environmental factors or have a much broader picture as what it has to do. It comes back to the point about, okay, but how do you put everything together? Because your DNA is fixed for your life, but your transcriptome, etc., and metagenome, they change over time. Yeah. So Illumina is making a lot of investments and efforts in the side of creating something you could compare with an App Store or Google Play Store for genomics, because we don't have unlimited resources to be able to build everything in the world. So we try to create the ecosystem where researchers across the world can put data, can put tools, and do bigger data cohort analysis. So you say, look, I take from across the world different populations with people that have early life diabetes, and see whether there's a genetic profile, maybe a proteomic profile, or looking just at the gut microbiome as to what could be the cause. So this is why I'm saying we're still really at the beginning of what we could do with the potential of genetics, and there's so much things still to achieve.
Well, in ideal world, every known condition, cancer could be profiled and get the treatment for what it is needed. Hopefully, we are moving towards, and things are developing. That science definitely is a driving force of this and translation of this science. But at the end of the day, we have to have access to it, and it should be covered. So we will really have to work together, and of course also with policymakers and payers in the end. But probably in near future things are changing, well, for individuals very slowly, but for society things are moving forward. As we have learned in the past 2 years, if everybody joins forces, something big can happen very quickly, and we don't have to wait decades for something to change. So maybe we have to learn also from this something, and how all of this could be connected and moving this progress even faster. Probably not in 10 years, but who knows, maybe even in 10 years.
The challenge is changing the system, right? So in many countries, people are getting reimbursed by doing a test for somebody that's sick. Like we have some revolutionary concepts in certain countries, like in Israel, where there's like a healthcare organization get a budget for the number of people that are into their system. Anytime the patient comes into the hospital, it's taking money out of their budget. So they're more incentivized not to treat people, but to not have the people come to the hospital. That's their incentive. So you try to keep people healthy. And that's a very good mindset as to how try to prevent disease rather than treating disease.
Maybe just from the perspective of a laboratory geneticist, my wish for the center would be for the interpretation of genetic data to be much easier, as Jarno already mentioned, because this is the bottleneck at the moment in the laboratory. It's easy to get data, but it's much more difficult to interpret it. And maybe in this context, I would just, 20 or more years ago, when I started with laboratory genetic work, this field was more like a one-man band. Every single person could do all the steps of the procedure, from the analysis to interpretation to the reporting. But nowadays, this is has become much more multidisciplinary thing. We have analytics, we have biostatisticians, we have physicians in this group, and this is really important because this is the way that the whole procedure is much more much more reliant, the quality is much higher, and I think that this is the way for the future, the multidisciplinary work from the laboratory to the physician with the inclusion of the patient, and of course this might yield the greatest results.
Does anyone have any last final thoughts? Otherwise, I would like to ask the audience if there's any questions that you want to address to our panelists.
I'm curious about the reimbursement program in Slovenia. How far away we are if we compare with the other countries. Maybe some of you know more in details about the Slovenia cases, or?
Yeah.
If you need it, you get it.
Yeah.
That's the case, and it's covered.
Yeah.
That's basically, it's not based on some so for example on diagnosis. In other countries, usually the reimbursement is based on if you have epilepsy, then you have this and this genetic testing. Here you can get always the exome or genome if the clinician decides that you need it. So basically it's in the hands of a clinician, specialist in the tertiary institution, or a clinical geneticist that can order the test, no matter the phenotype actually. So because the phenotype of the rare disease is so different that we cannot actually pinpoint, okay, if you have the seizures, then you get this kind of test. If you have the developmental delay, then you have this kind of test. So basically we put everything into and it was much effort from our colleagues in Dr. Peterlin's lab and in our lab in Maribor. Basically all genetic labs step together and push this kind of agenda to the insurance company. So basically we have one, I think, very adaptable system where we can cover the broadest possible population.
Thank you very much.
In comparison to other countries, we are maybe much more closer to Germany and Netherlands than other neighboring countries.
Yes.
Austria and Italy, I won't go to the east and south because they don't have any of this. But even in comparison to Austria, Italy, Spain, France, we, especially in this kind, and also in other chronic diseases like rheumatoid arthritis and other conditions or neurological conditions. Actually, if clinicians and if there's a clinical need, but we don't have it as a screening, especially except for neonatal screening.
The advantage for you is that things are decided on a country level, right?
Yes.
Where some, like in Italy, you have
It's
like
regional.
there could be a country policy,
In North,
but
you have
then
everything.
all the
in
regions
South,
decide
you don't
themselves.
have
Yes.
anything.
That's the advantage of small country.
Yes,
Yes.
exactly.
Any other questions or remarks, comments? If not, then we can conclude today's discussion. Thank you all the speakers for sharing your insights. Thank you everyone that joined the event today.
Thank you.